What's up everybody, and welcome to another video of my What's Machine Learning series. In the previous videos we have seen how machine learning works at a high level and also how it works in detail using a decision tree as an example. In this video I want to talk about some applications of machine learning. And as you can see, there are quite a few that I want to talk about, so if you don't want to watch the whole thing, or if you're just interested in a particular example, then I've put the timestamps to the individual applications into the video description. But by showing so many different examples, I hope the huge variety of possible use cases of machine learning comes across. Before I start, however, I want to quickly mention that I'm not linked to or paid by any of those companies. I just want to show them to demonstrate that there are concrete real-world examples where someone is using machine learning to solve a problem and someone else is willing to pay for or invest in that product or service. So to start off, I'm just going to rattle off some of the more well-known examples, which for instance are spam detection for email accounts, fraud detection for credit card usage, self-driving cars, recommendations for what other products or movies a customer might like, finding the most useful results for search queries, personalization of a user's feed or determining to which user a certain ad should be shown, speech recognition for virtual personal assistants, and face recognition, for instance, for applying filters to videos. So those are some of the more well-known examples. And now let's go into a little bit more detail with the maybe lesser known applications. And the first one comes from Dango. And this is a service that predicts which emojis you're going to use based on the message you've written. And the training process for such a service is pretty straightforward. All you need are many example messages, and then you show the algorithm the text message, and the label is which emojis have been used. And then once the algorithm is trained, you can show it a new message, one it hasn't seen before, and then it will be able to predict which emojis are most likely the ones to appropriately represent the content of that message. And then it accordingly recommends those. And on their website, you can also play around with the app. So if you, for example, write shuttered, then it shows the hand emoji or the cactus emoji. Or if you, for example, write Michael Jordan, then it recognizes that it has something to do with basketball, and it also recommends the GOAT emoji because Michael Jordan was the greatest of all time. So that's Dango. The next example, Swiftkey, does something similar, but instead of predicting emojis, it predicts the next word you're going to write based on what you've written so far. So for example, if you write, I will meet you at the, it will predict that the next word is going to be airport, hotel, or office. And then you can simply tap on those words instead of typing them. So the app should help you to write your messages faster. The next example comes from Textio, and they use machine learning to predict the performance of job listings. And therefore they analyzed millions of job postings, and the metrics that they used to determine the quality of those postings were how many people applied to the posting, how many of them were actually qualified, how long it took to fill the position, and the gender distribution of the applicants. And with that, they can now provide a service in the form of a text editor. And here you can simply insert your job listing, and then Textio will predict how good it will perform in terms of the just mentioned metrics. And therefore then it calculates this overall score, which represents the percentile that job listing falls into compared to other job postings for the same role and same location. And because of their extensive analysis of all those job postings, they can now give you also some direct and concrete feedback. So for example, those orange highlighted expressions are expressions that usually don't perform well in job listings. So if I scroll up again, then for example here, instead of writing outside the box, Textio suggests that just writing creative would be better. And that's because this seems to be more attractive to potential applicants. And if you then insert that word, your score will improve. And then by going through all those recommendations, you can step by step improve your score, and therefore make your job listing more attractive to potential applicants. So that's Textio. Another interesting example for what you can do with machine learning comes from Tessian. And the problem that they are addressing are data security breaches caused by inadvertently misaddressed emails. Normally, a lot of data security providers try to protect the companies by making sure that their technology doesn't get compromised. But the employees of those companies are also a great risk, and that's because there's a huge amount of sensitive information in the emails that they write. So what Tessian does is it analyzes the content of the email and it checks it for potentially confidential information. And if it finds something, it warns the employee that this email might be addressed at the wrong person. And that way Tessian helps to avoid inadvertently disclosing sensitive information. The next example comes from DigitalGenius, and they deal with the fact that today customers can directly interact with companies via social media. And the more and more people do that, the more the companies start to struggle to respond to all these requests. And that's why chatbots are a huge field for machine learning. And what their chatbot does is it automatically analyzes a request, for example, what the priority is, what the sentiment is, or what it's generally about. And based on that, then it routes this request to the department that would be responsible for that. And then more importantly, it also automatically creates an appropriate response. And the customer service rep then only has to approve or slightly personalize that. And the chatbot also calculates a percentage which shows how confident it is that this response is an appropriate response. And here the customer service rep can also set a threshold above which the chatbot then automatically responds to requests. So for example, if you would set the threshold here to 95%, then this particular response would have been sent automatically. So that's DigitalGenius. Next is x.ai, and they also use a chatbot approach, but instead of dealing with customer requests, they deal with scheduling meetings. So if someone sends you an email and they want a meeting with you, then you simply answer that email and write amy@x.ai into the CC field. And that's the chatbot. And then the chatbot takes care of the back and forth of scheduling the meeting, and once a date is agreed upon, it will be saved into your calendar. So that's x.ai. Next is Atomwise, and they use machine learning to improve the process of drug discovery, and they use computer vision to do that. And to understand what they do, we have to have first a little understanding about drug discovery in general, namely that certain diseases are caused by certain proteins. The proteins can either inhibit or enhance that disease, and the proteins in turn are influenced by molecules, and their relationship can be described as a lock and a key. The protein is the lock, the molecule is the key. And so drug discovery is then about designing the right key for a given lock so that you can eventually cure the disease. And this is an extremely difficult process because for every molecule that eventually becomes a drug, millions might have to be physically tested and then discarded as unsuitable. And this results in extremely high costs for bringing a drug to market. So it is extremely important to focus your efforts on the most useful molecules or the most promising molecules. And that's where machine learning comes into play. Because what Atomwise did, they used a convolutional neural net and they showed it different combinations of proteins and molecules, so of locks and keys. And the label was if that particular combination was effective or not. And then once the algorithm is trained, you can now virtually design many different molecules for a given protein and show them to the algorithm and see what it predicts. So for example, maybe it will predict that for key number 1, there's a probability of 10% of being affected. Key number 2, 90%, key 3, 60%. Then you would obviously focus your efforts on key 2 because the most promising one. And that's how Atomwise can save a lot of time and resources in bringing a drug to market. So that's Atomwise. Next is Alphasense, and they are a service addressed at professionals working in the financial industry. And they obviously have to research a lot to make sound investment decisions, and that's exactly where Alphasense comes into play. They go through millions of documents from many different sources, and then they index those documents. And to get a sense for how many sources there are, here's a list of them. So those documents might include some primary research, so documents that have to be published by the companies themselves, research documents by brokers, or documents from regulatory institutions. And the list goes on and on and on. So clearly there's way too much to read. So what Alphasense basically is, it's a search engine for all those documents so that you can find the critical information that you need faster. So that's Alphasense. Next is BenevolentAI. And they do something similar as Alphasense, only in the field of science. And here too, there are simply too many research papers published to read for scientists to read them all. So what BenevolentAI does at a high level is it goes through all those research papers, and from the knowledge that it builds from that, it can create new hypotheses that can then be further investigated by the scientists. So it's basically a tool for accelerating scientific innovation. And the field that they first decided to focus on is drug discovery, so just like Atomwise. But they have an entirely different approach. They first feed in all those research papers into their systems, and then they annotate all the words that are related to pharmaceuticals or drug discovery. In the next step, they use natural language processing to understand all the relationships between those words. And from those relationships, they then build a knowledge graph, which can then be used to derive inferences and create new hypotheses. So for example, let's say one research paper found that a certain protein causes a certain disease. And then another research paper found, or another research paper which was completely unrelated to that disease, found that a certain molecule inhibits that protein. And now you can derive the inference that that molecule can be used to maybe cure that disease because it inhibits the protein which causes the disease. And these are the kinds of hypotheses that a system come up with and then can be further investigated by the scientists. And obviously this is an oversimplification of the process, but that's how I understood it to work. So that's BenevolentAI. Next is Clarifai, and they work in the field of image recognition. So their service can automatically recognize the content of images, and then it accordingly tags the content. And this makes it much more easier to search and also to organize. And you can also curate it more effectively, meaning that you can, for example, delete inappropriate content. And this obviously might be extremely interesting to social media sites like Facebook or Pinterest. And the cool thing is that they also have a demo that you can play around with. So this is the demo, and here at the bottom there are some preloaded images, and here on the right you can also upload your own images. And on the top there are the models that should be applied to the image. So the different models are simply specialized in recognizing different things. The general model, for example, recognizes the general content of an image and also the objects within the image. So in this case, it recognized that it's about nature and that there's a squirrel, some wood or tree, and it also recognized the nut that the squirrel is holding. Another model is the face model, and as the name says, it detects faces. So in this case, it didn't detect any face, but here it detects two faces. And here on the top right corner, you can even add more models. And one that I found particularly interesting is the demographics model. And that's because it also predicts the age of a person. And so then I uploaded an image of myself, and sure enough, the prediction of my age was pretty accurate. So that's Clarifai. Next up is Affectiva. And they do something similar as Clarifai, but they are only specialized in facial expression and then recognizing human emotions. And they also have the world's largest database of human emotions with more than 6 million faces analyzed. And here too, there are also some demos that you can play around with. In one demo, for example, monitors your emotions while you're watching a YouTube video. So here I already did that, and you can see at which point in the video certain emotions were triggered and also how strong they were triggered. So in this instance, here at the beginning there was some surprise, and after that some anger. And I think it's pretty clear how such information would be extremely interesting to, for example, advertisers or content producers to see how engaged their users are. So that's one demo. In another demo, you can search for GIFs using your emotions. And I think this really might become a feature at some point in the future for messaging apps, because your smartphone then can simply monitor your emotions while you're reading a text message. And then once you're done, it can automatically recommend a GIF that might be an appropriate answer to that message. So that's Affectiva. Next is OrCam. And they use computer vision to help visually impaired or blind people to see the world. So what they did is they built this camera that you attach to the glasses, and then simply by pointing at things, it will read out aloud the text that it sees. And another feature is that you can also save the faces of your friends and family. And that way, OrCam then can automatically tell you who's in front of them, or in front of you, as soon as it recognizes one of those faces, without the need for you to having to do something. And still another feature is that you can save certain products, so that you then are able to go to the supermarket on your own. So that's OrCam. Next is Zebra Medical Vision. And they work in a field that is going to be hugely affected by machine learning, namely medical diagnosis via any sorts of scan. So for example, X-rays, MRI scans, or CT scans. And here you simply show the algorithm such a scan, and then it will be able to say, for example, okay, here and here there's a fracture. And this approach can be basically done with any injury or disease that can be analyzed using scans. So that's Zebra Medical Vision. Next is another industry that's also going to be affected by machine learning, namely agriculture. And an example how you can do that comes from Blue River Technology. What they did is they built this trailer that you attach to your tractor and then pull over your field. So here's another picture of that trailer, and in that trailer there are cameras which can detect which plants are crops and which plants are weeds. And then the trailer can precisely spray herbicides just on the weeds, instead of spraying the herbicides all over the field. And that way you can obviously reduce your costs and also increase your yields. So that's Blue River Technology. And now the last example comes from still another industry that's going to be affected by machine learning, which is data security. And an example company that works in that field is Darktrace. And what they do is they try to detect anomalies in your network by analyzing data about user behavior. And the interesting effect about them is that in contrast to all the other examples that we've seen so far, they use unsupervised learning. And as you may remember, in the first video of this series, I briefly talked about unsupervised learning. And in the context of the iris flower dataset, unsupervised learning meant that the label which described which type flower is wasn't included in the data. And I think if you look at this graph now, it becomes obvious why Darktrace might be using unsupervised learning to detect anomalies. So let's say that this would be data about user behavior on your network, and each dot represents one specific activity. Then I think it's clear that here on the right side, where most of the data points are, those are probably data points that represent normal behavior on a network. And here on the left side, the data points that are clearly separated from all the other, they are probably data points that represent some kind of anomaly that you then have to address. So that's how unsupervised learning might be used in the field of data security. And now, to wrap up, by showing so many different examples, my goal for this video was, on the one hand, that you can get a feeling or understanding for what can be done with machine learning, and on the other hand, and maybe even more importantly, by showing such a breadth of different examples ranging from the supposedly trivial, like predicting emojis, to potentially life-saving applications like medical diagnosis, I wanted to demonstrate that the possibilities or use cases of machine learning are really only limited by our own imagination. And I think this realization raises one important question, namely, given that machine learning can be used to solve so many different problems, what might be some possible implications of that? And this will be the topic of the upcoming video, which is also the last one of this series. So, thanks for watching, and hopefully I will see you in the next video.